everyone. My name is Eva Maronova, and I'm a PhD student at the Royal Veterinary College in London. And today I'm going to talk to you about our research into smartphone-based pelvic movement asymmetry measures for clinical decision-making in equine lameness. Our study was funded by the Royal Veterinary College, which is also funding my PhD. In terms of competing interests, one of the authors is the owner of Equigate Ltd, which provides gait analysis products and services. Our study was approved by the RVC Social Science Research Ethical Review Board, and no informed consent was required due to the retrospective nature of this study. Use of technology is gaining popularity in clinical setting. Due to its accuracy and portability, a great proportion of gait analysis is now carried out using wireless inertial motion units, or IMUs for short. While IMU-based systems are now widely utilized by large equine practices, the equipment can still be financially out of reach for some, especially for smaller practices. And since smartphone-based asymmetry measures have been validated against IMUs, smartphones could become a useful tool to aid clinical decision-making. Our research focused on hind limb lameness, as it's been shown to be more challenging to identify even for experienced clinicians. Therefore, the aims of our study were to investigate sensitivity and specificity of 3 smartphone-derived pelvic movement asymmetry measures compared to an expert's visual assessment, and to investigate thresholds for different lameness grades based on this individual's opinion. We hypothesized that the asymmetry measures will have distinct thresholds for various lameness grades for all 3 pelvic parameters. Our data was collected over 3 years at a veterinary clinic in Switzerland and consisted of 301 horses. The age range was from 3 to 26 years, and with the mean of 12.8 years. We had a variety of breeds, but the majority were warm bloods. The horses were assessed visually on straight line and trot, and smartphone data was collected at the same time. One experienced clinician assigned a lameness score for hind limbs from 0 to 10, and that's based on UK equine lameness score. And this was done before the smartphone asymmetry data was evaluated in order to eliminate any bias. We used the absolute values of the asymmetry parameters in our analysis, just because our focus was on the comparison of the magnitude of movement asymmetries and the lameness scores, regardless of whether the asymmetry was assigned to the left or the right limb. The 3 pelvic asymmetry measures that we evaluated are shown here graphically. On the graph here, we evaluated the PD min, which is the difference between 2 minima in vertical displacement of the sacrum, so marked here on the graph. And that's the PD min. And this relates to the difference in weight bearing between the 2 limbs, and sometimes it's labeled as impact lameness. Then we have PD max, which is the difference between 2 maxima in vertical displacement of the sacrum, and that relates to the difference in propulsive forces, sometimes labeled as push-off lameness. And that will be marked over here in the PD max. And then the PD up, which is the difference in vertical movement upward amplitude. So here we have amplitude 1, amplitude 2, and then the difference will be PD up. Since our data were not normally distributed, we used Kruskal-Wallis test with one for only post-hoc pairwise comparisons to evaluate differences between lameness grades. In order to investigate sensitivity and specificity of cutoff points for different lameness grades, we plotted the receiver operating characteristic curves based on the absolute asymmetry measures and subjective lameness scores. And finally, we use the area under the curve to assess the overall quality of each asymmetry parameter to sort of for them to differentiate between lameness grades. The horses in our study were assigned lameness grades from 0 to 5, so we didn't have any horses with a score of 6 or above. This meant that we could also examine asymmetry parameters in lame horses, but also in non-lame horses. Since we only had 4 observations for grade 5, these observations were excluded for any additional statistical analysis apart from the basic descriptors. Now the box plot here is representing the distribution of the absolute values of PD min. And this trend was pretty similar for the other 2 parameters. For the overall statistical difference, we found that there was a statistical difference overall. And also the majority of the paired differences were statistically significant. However, this was not the case for lameness grades, which were just 1 grade apart. So, for example, grades 1 and 2 or 2 and 3. So there were no differences between grades that were just next to each other. Interestingly, for the PDF, there was a statistical difference between grade 0 and grade 1. So that is between non-lame horses and very mildly lame horses. So this parameter in that particular case would perform the best. Overall, we observe increasing asymmetry values with increasing lameness scores, which is in agreement with previous research. In clinical studies, there is often mentioned a threshold of 4 millimeters for the PD min and PD max parameters. And in our study, we found that the medians for grade 0 were 5, and the median for grade 1 was, so grade 0 was 4, and then for grade 1 was 5 millimeters, and that was both for PD min and PD max. Now, this would suggest that this particular clinician's subjective threshold was in agreement with previous studies. On the other hand, we also know that for only sound horses, so those are horses that are in work and are not considered to have a lameness issue, and also in thoroughbreds in training, these asymmetries for PD min and PD max are often found to be about the 4 millimeters. So the evidence for a fixed lameness threshold is definitely not conclusive. Based on the area under the curve, the PDAP was the parameter which had the highest discriminative power across all conditions. Now this could be seen here from the graph where the PDAP is represented by the green curve, and that one is the one that's closest to the top left corner, which means that this parameter has the highest specificity for any given level of sensitivity. So ideally you want to have the best parameter as close to the top left corner as possible, and definitely the PDAP outperforms the other parameters in this particular study. In contrast to other studies, the PD min actually was found to have the lowest discriminative power, which is the opposite of what was found in the racehorse study, where the PD min had higher AUC than the PD max. Also, PD min has been found to be associated with difference in peak forces between contralateral hind limbs, and it's been shown to consistently change in response to positive diagnostic blocks. Now, one of the possible explanations could be that this particular vet was looking at the upward movement differences more, so he would not necessarily pick up on the differences and minimize much and label those horses as lame. While we investigated cutoff points with minimum set specificity and sensitivity across all lameness grades, today I'm only going to discuss the cutoff points with high sensitivity, as these are the most relevant for clinical setting, where the first task is to identify the most affected or the affected limb. With set minimum sensitivity of 75%, so that was our threshold, the PD min and PD max between non-lame and all lame horses, so both of those thresholds were below or very close to the 4 millimeter asymmetry thresholds. However, we also noticed that the specificity was quite low, and that could result in overclassifying horses as lame when they were not in fact lame. Just to note here, the PDAP parameter had much higher sensitivity, so it could perhaps be a useful additional tool for lameness exams. So to conclude, smartphones can aid clinical decision making, especially in situations where most sophisticated equipment is not available. And in our study, measuring the difference between pelvic upward movement amplitudes, or the PDAP, showed the highest value for sensitivity and specificity. Therefore, this parameter could provide valuable information in addition to parameters linked to difference in pelvic minimum and pelvic maximum. Thank you for listening, and I look forward to receiving your questions.